Hi, the objective of this third video on synthetic division is to frame the roots of a polynomial. In first, we'll verify if all the roots of a polynomial are larger than a real number a. In second, we'll verify if all the roots of a polynomial are smaller than a real number b. I'll be using the C language for this tutorial. A link in the description will take you directly to the work page. This is a work page, a wikibook. You must first download the hash files. You can find here the hash file. You can then download the first example, a C file. Synthetic division. The long division of polynomials can involve many steps and be quite cumbersome. Synthetic division is a shortcut that can be used when the divisor is a binomial in the form x minus k, where k is a real number. In synthetic division, only the coefficients of the polynomial are used in the division process. Can you explain how to verify if all the roots of a polynomial are larger than a real number a, using synthetic division and the C language? Yes. If all roots are greater than a, then using synthetic division with the binomial x minus a, the coefficients in the first row must alternate in sign. The coefficient in the third row must alternate in sign. Now I try an example. This is the example. I copy this file into my editor. Alors, the degree of this polynomial is 4. This is the coefficient of the polynomial. It is an array. In first, I choose for a minus 4. In the second, I choose for a the value minus 8. I want to plot the polynomial into Gnuplot. I call Gnuplot. I copy the truc. Now, this is my polynomial. I see here a root, another root, another root, and another root. For the first value of a, I have chosen minus 4. Here, minus 4. I can see if I choose minus 4, on the left there are a root. In the second part, I have chosen minus 8 for the value of a. I can see if I choose minus 8, all the root of this polynomial are on the right. this is the polynomial. I have chosen in first minus 4 here. The first row does not alternate in sign. The first row does not alternate in sign. Plus, minus, minus, plus, minus. The first row does not alternate in sign, so minus 4 is not a lower bound for the root of p of x. Now I have chosen minus 8 here. The first row alternate in sign. Plus, minus, plus, minus, plus. So minus 8 is a lower bound for the 0 of p of x. So minus 8 is a lower bound for the root of p of x. If I choose, now I choose 20 for example, instead of 8. Alors, the first example is minus 4, plus, minus, minus. So, the first row does not alternate in sign, so minus 4 is not a lower bound for the root of p. Now I have chosen minus 20. Minus 20 is on the left. The first row alternate in sign. Plus, minus, plus, minus, plus. So minus 20 is a lower bound for the 0 of p. Minus 8 is better, but you must use also minus 20, for example. Minus 8 is better, but you can use another value, for example, minus 20, minus 30, minus 222. Now we can try a new example. This polynomial is of degree 6. This is the coefficient of the polynomial. It is an array. For the first value of a, I chosen here the value minus 1. For the second part, I have chosen minus 2. I want in first draw the polynomial into Gnuplot. Okay. I have chosen for a in first minus 1. Minus 1 is here. I can see there is a root on the left, so minus 1 is not a good value. In second part, I have chosen minus 2, a value of a minus 2. Minus 2 is here. All the root of this polynomial are on the right, so minus 2 is a good value. Now I try this example in C language. You can find here the polynomial. In first I have chosen minus 1. Minus 1 is here, is not a good value, because on the left there is a root, and the first row does not alternate in sign, So minus 1 is not a lower bound for the root of p of x. Plus, minus, plus, 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 plus. Minus, 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 minus. The first row does not, the coefficient of the first row does not alternate. Now I have chosen minus 2, the value of minus 2. Minus 2 is here. All the roots are on the right of minus 2. The first row alternate in sign, plus, minus, plus, minus, plus, minus, plus. So minus 2 is a lower bound for the 0 of p of x. Now, for example, I put ici 35, for example. Yes. In first, it is minus 1. The first row does not alternate. Plus, minus, plus, 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 plus. Minus, minus. The first row does not alternate in sign, so minus 1 is not a lower bound for the 0 of p of x. I have chosen minus 35. The first row alternate in sign, plus, minus, plus, minus, plus, minus, plus. So minus 35 is also a lower bound for the root of p of x. 35 on the left is also a lower bound for the root of p of x, but minus 2 is better. Minus 2 is better. It is more near the root than 35. Okay. Alors, yes. Alors, can you explain how to verify if all the roots of a polynomial are larger than a real number a using synthetic division and the C language? Yes. If all roots are greater than a, then using synthetic division with the binomial x minus a, the coefficient in the first row must alternate in sign. So, if the coefficient in the first row alternate in sign, you have with a, you have a lower bound, you have a lower bound for the root of p of x. You have a lower bound for the root of p of x. Thank you.